In this video, we want to take a look at homogeneous system solutions, or solutions to homogeneous systems. So what does it mean to have a homogeneous system? It means I have a linear equation that I can write in the form ax equals 0. That is how I know it's called homogeneous. Now, it makes sense that every homogeneous system would have a trivial solution of x equals 0. And what I mean by that is, if you'll recall, ax means I've got some matrix A, and it's multiplied by some vector x, and we're saying that that's equal to 0. So that's a homogeneous system. Why does it make sense everything will have a trivial solution? Because if I replaced all of my x's with zeros, then it would make perfect sense that a1 times 0 would be 0. Because remember, 0 is just the 0 vector. 0, 0 is all the zeros. A1 times 0 is 0. A2 times 0 is 0. And we get the idea that it would make perfect sense that no matter what I have here, if I have zeros in my vector, then my solution will be 0. What we want to know is there some value for x, and we're talking about vector x, not just some variable. We want to know, is there some solution set that makes the matrix times the vector also equal to 0? For instance, if I take a look at this matrix equation, if I took 2 times 1 plus negative 2 times 1, that would be 0. And if I took negative 1 times 1 plus 1 times 1, that would be 0. And we can see that these are equal to 0, where this is a, and this is x, and this is 0, where x doesn't equal 0. X itself doesn't equal 0, but when I multiply it by a, the solution is 0. So that's an example of a non-trivial solution. Now, what would happen if instead of 1, I change these to 3's? Now what do I have? Well, 2 times 3 is 6. Negative 2 times 3 is negative 6. Yes, that still works. Negative 1 times 3 is negative 3. 1 times 3 is 3. And yes, that still works. So I could change my x vector to anything I wanted and still have a solution. And so what that tells me is I have a great many solutions, and whatever the solution is dependent on some free variable. So that's how we know that we must have at least one free variable. What's that going to look like if I were going to graph that? Well, I would graph that if I had just one free variable. It would end up looking like a line that goes through the point, in this case 0, 0, 0, because I've drawn this with 3 dimensions, or 3 variables. And if I just had one free variable, then it would look something like that. And the changes, or what makes the line, is I'm changing the value of, say, x1, and that is going to in turn change the value of x2 and x3 because they were based on x1. If I end up with 2 free variables, say x1 and x2 are both free, then x3 is going to vary based on what I change x1 and x2 to be. So it's going to end up looking more like a plane, again, still crossing through that same point. So what I want to do is go through an example with you where we actually find what is our free variable and what are our other variables in relationship to that free variable. So here's an example. We have an augmented matrix, and I want to first write it in the form where I have A on the left side, and A is going to be an echelon matrix, and 0 obviously is the 0 vector. So what I want to do is I essentially want to change these values all into zeros and to have my pivots at 3 and negative 2. So let's take a look. Obviously, we should be really good at those row operations by now. Row 1 is going to remain the same. Row 2 I would take row 1 plus row 2 to get 0, 3, 0, 0. Row 3, I would take negative 2 times row 1 plus row 3, and that would give me 0, negative 9, 0, 0. Now, from here, I want to continue, and I really want this guy, of course, to be my pivot, which means below that, I still would like to have a 0, because at first I just want to look at echelon form. So what's going to happen now is not a darn thing on row 1. Row 2, not a darn thing. Row 3, I'm adding 3 times row 2 to row 3, so 0, 0, 0, 0. So at this point, before we continue, what does this tell me? This tells me, again, keep in mind this is the x1s, x2s, x3s. I've got a pivot in x1 and a pivot in x2, and obviously no pivot in x3, which tells me that x3 is free. Now what I want to do from here is continue my row operations so that I have, instead of 3s where my pivots occur, I would like those to be 1s. So for instance, I might take a third of row 1 to get 1, 5/3, negative 4/3, 0. And a third times row 2 to get 0, 1, 0, 0, and row 3 would remain unchanged. And then I would take it one step further, because if I have a 1 here, then this guy must be a 0. So I'm going to take negative 5/3 times row 2 and add it to row 1. So now I have 1, 0, negative 4/3, 0, 0, 1, 0, 0, and 0, 0, 0, 0. So in our last video, this is kind of where we ended, and we said, great, here's my solution set, because this, of course, is x1, x2, x3. So instead of writing x1 minus 4/3 x3 equals 0, we said x1 is equal to 4/3 x3. And x2 is equal to 0. And x3, we already said, is free. So that's kind of where we stopped on the last video, and I want to continue now just a little bit further, because that's what we do in mathematics, is we just always keep pushing and pushing and pushing. So what am I going to do from here? Well, let's say I wanted to write this instead as a vector, because that's what I want, is vector x to be x1, x2, x3. So vector x then, based on this guy, is that x1 can be written as 4/3 x3, x2 can be written as 0, and x3 is free, so I'm just going to write x3. And what I notice now is that my terms have an x3, so I'm actually going to take x3 out of it and write this as 4/3, 0, 1. So what I have is that my solution is now some constant x3, which I don't know what x3 is, but some constant x3 times vector v. So this brings us to parametric vector form, and parametric vector equation essentially says that I can write x as some constant times some vector. And so essentially what I'm saying is that x3 is t, because I want to write it as t v, and that's what I have, is I have now written this as in the parametric vector equation form. Here's one for you to try before we make things a bit more complicated. So this should be pretty straightforward like our last example. So if you would press pause, try to do what we did on our last equation, which is to turn this into reduced row echelon form and then write it as a parametric vector equation or parametric vector form. So again, the first thing that I would do is I want these guys to be zeros. So I already have 1, 0 exactly where I want it. 0, 3, 6, 0. And then I would just take row 1 minus row 3. So that gives me 0, negative 3, negative 6, 0. From here, I can see I'm going to have a pivot here at 3. So that means I need this guy to be a 0. And it looks like I can just add rows 2 and 3 together, which is going to give me row 1 exactly as I had it. I haven't touched row 1. And that's often the case. This guy is 0, 3, 6, 0. And then row 2 plus row 3 gives me 0, 0, 0, 0. So again, I can see that x3 is free. Now, don't think x3 will always be the free variable. That's just what we ended up with in this case and in our last example. From here, I'm going to continue doing my row operations. So I'm going to end up with, let's turn this guy into a 1. So 4, 2, 3, 0. Let's take everything in row 2 times a third. And obviously row 3 is remaining exactly the same. And now I really want this guy to be a 1 if possible, but more than that, I really need this guy to be a 0. So I'm going to continue. I'm going to leave the 4 alone for now. I'm going to take negative 2 times row 2. So that's going to give me 0 here. So that's negative 4 plus 3 is negative 1. In this row, nothing changed. In this row, nothing changed. So I'm getting closer to where I want to be. And again, you don't have to in this step, but I'm going to. I want this guy to be a 1. So I'm going to take a fourth of everything. So that's going to give me 1, 0, negative 1/4. This guy is 0, 1, 2, 0, and then 0, 0, 0, 0. So again, the way that we did this before, we wrote it, oops, I was going to change color there. We wrote it as just a set. I'm going to go ahead and write this as x1, x2, x3. So what does that give me? Well, x1 minus 1/4 x3 is equal to 0, so x1 is equal to 1/4 x3. x2 plus 2x3 is equal to 0, so x2 is equal to negative 2x3, and then x3 is free, which means, again, if I factor out x3, then I have 1/4, negative 2, 1. So again, I'm able to then say that this is in fact in the correct parametric vector form because I have some constant t times some vector v. And that's exactly what I wanted. Let's do one more example here, and in this case I want to look at what happens when we have more than one free variable. So again, it looks like I already have this one exactly where I want it, and that's a pivot. And this guy is a pivot. I already have this guy is a 0. I need to turn this guy into a 0. So what I'm going to do is I'm just going to rewrite this one so I don't change a darn thing there. And row 1, I want this 2 to be a 0. So I'm going to take negative 2 times row 2 plus row 1. So negative 2 times 0 plus 1 is 1. Negative 2 times 1 plus 2 is 0. Negative 2 times 3 plus negative 2 is negative 8. Negative 2 times 2 plus 5 is 1, and of course 0. So what I have now is similar to what I had before, and we can see that x1 and x2 are assigned and basic variables essentially. x3 and x4 are both going to be free variables. So how am I going to write this? Well, I could say that x1 minus 8x3 plus x4 is equal to 0, and that x2 plus 3x3 plus 2x4 are equal to 0, or is equal to 0. And if I'm then writing my solution, x1 would be 8x3 minus x4. x2 would be negative 3x3 minus 2x4. x3 would be x3 because it's free, and x4 would be x4 because it's free. And so now I can write this a little bit differently. I can say this is 8x3, negative 3x3, x3, and 0, plus this guy is negative x4, this guy is negative 2x4, this guy is 0 because there's no x4, and this guy is just x4. So now what I can do is I can say that x is equal to, again, factoring out that x3, I end up with 8, negative 3, 1, 0. And factoring out x4, I get negative 1, negative 2, 0, 1. And again, is this written in parametric form? Well, parametric form, when we have more than one value, essentially is SU plus TV. Again, U and V are vectors. So does this fit that? Yes, we've got S is that constant of x3, U is our vector, T is our constant of x4, V is our vector. So now we have this in the correct format for parametric vector form.